All right, guys, let's look at section 3.3 now. So we start section 3.3 with the introduction of the corresponding angles converse. Okay, now remember the converse of a statement is when you switch the hypothesis and the conclusion. So the corresponding angles theorem told us that if two lines are parallel, then the corresponding angles are congruent. So the corresponding angles converse says the exact opposite. If the corresponding angles are congruent, then the lines are parallel. So you would use this to show that lines are parallel. So when we know corresponding angles are congruent, we can conclude that the lines are parallel. Okay, so let's look at example 1 here. It says find the value of x that makes m parallel to n. Okay, well, in order for m to be parallel to n, the corresponding angles, which is right here and here, have to be congruent. Well, if they're congruent, then that means 3x plus 5 has to equal 65. Now just a little bit of algebra here. So 3x equals 60. Divide both sides by 3. That means x is 20. Okay, now let's look at another example. It says, is there enough information to conclude that lines m and n are parallel? All right, so in order for them to be parallel, the corresponding angles have to be congruent. Well, guys, notice this and this are not corresponding angles. Okay, on first thought, you would see, no, it's not possible then. But let's dig a little bit deeper. Okay, if this angle here is 105, what do we know has to be the measure of this angle here? Okay, well, they are a linear pair, and we know linear pairs are supplementary, so this has to be 75 because 75 plus 105 is 180. Now, if we know this has to be 75, don't we have that corresponding angles are congruent now? So the answer here would be yes by everything I just said. All right, guys, now let's look at this. So we have more than just the corresponding angles converse. We also have the alternate interior angles converse, which just says if we know that alternate interior angles are congruent, then we can conclude that the lines are parallel. Same thing with the alternate exterior angles converse. If those are congruent, then the lines are parallel. And then consecutive interior angles, now remember this is kind of the odd man out. If we know that consecutive interior angles are supplementary, then we know these lines are parallel. All right, let's look at a proof now. So it says, prove that if two lines are cut by a transversal so that the alternate interior angles are congruent. So we're given that the alternate interior angles are congruent. So in this case, that's angle 4 is congruent to angle 5. Then the lines are parallel. Okay, well, we're given that angle 4 is congruent to angle 5. Okay. Now, we can also tell that angle 4 is congruent to angle 1 by the vertical angle congruence theorem. So if angle 4 is congruent to angle 5, and angle 4 is also congruent to angle 1, that means that angle 1 has to be congruent to angle 5 by the transitive property of equality, or if you like to use substitution, you can use substitution there too. Now, if angles 1 and angle 5 are congruent, guys, can't we use the corresponding angles converse to show that G is parallel to H? Because the corresponding angles converse tells us that if we know corresponding angles are congruent, and angle 1 and 5 are corresponding angles, and we've shown right here that they're congruent, then that means the two lines have to be parallel. So that's our proof. All right, here's another proof. Okay, it says in the diagram, R is parallel to S. I'm going to go ahead and write it down. R is parallel to S, and angle 1 is congruent to angle 3. I want to prove that line P is parallel to line Q. All right, I always start with my given. So R is parallel to S, and angle 1 is congruent to angle 3. Both of these are given. All right, if I look at this diagram, guys, I'm given that this and this are parallel. Okay, so that means that angle 1 and angle 2 have to be congruent because of the corresponding angles theorem. Angle 1 and angle 2 are corresponding angles, and we do know that S and R are parallel, so corresponding angles are congruent. So 1 and 2 are congruent. So if angle 1 is congruent to angle 3, and angle 1 is also congruent to angle 2, that means that angle 2 has to be congruent to angle 3. Okay, so that's the transitive property, and if you like substitution better, that's fine. Now notice, what is the relationship between angles 2 and angle 3? Well, guys, angle 2 and angle 3 are alternate interior angles, and we are given a theorem that tells us when the alternate interior angles are congruent, then the lines are parallel, and that's the alternate interior angles converse theorem. And therefore, we can conclude that P is parallel to Q. All right, I'm going to help you get started with this one, and then I want you to try to work it through on your own. So it says, use the diagram below to prove that alternate interior angles converse. Okay, so we're given that angle 1 is congruent to angle 8. And we want to prove the alternate interior angles converse, which would just tell us that J is parallel to K. Okay, so I'm going to pause this. I want you to try to work through it the best you can, and then we'll go over it. All right, let's go over this. Now, I'm going to label this angle just as angle 2, just to kind of make our lives a little bit easier. So I'm going to start. Angle 1 is congruent to angle 8. That's given. Okay, but I also know that angle 1 and angle 2 are congruent because they're vertical angles, and vertical angle congruence theorem tells us that all vertical angles are congruent. So angles 1 is congruent to angle 2. Now I know that angle 1 is congruent to angle 8, and angle 1 is also congruent to angle 2. Therefore, angle 8 has to be congruent to angle 2 by the transitive property, or if you like substitution, substitution will work there too. Well, guys, if I look up in this diagram, what is the relationship between angle 2 and angle 8? Angle 2 and angle 8 are corresponding angles, and the corresponding angles converse theorem tells us if corresponding angles are congruent, which we've shown right here that they are, then the lines are parallel, so I can conclude that J is parallel to K by the corresponding angles converse theorem. All right, let's look at a couple more examples and then we will be done. So the transitive property of parallel lines tell us that if two lines are parallel to the same line, then they are parallel to each other. So kind of like if two lines are equal to the same thing, they're equal to each other. If two lines are congruent, they're equal to each other. So if I look at this flag, it says the flag of the United States has 13 alternating red and white stripes. Each stripe is parallel to the stripe immediately below it. Explain why the top stripe is parallel to the bottom stripe. All right, so if I write this out, I know that stripe 1 is parallel to stripe 2. It tells us one after the other is parallel. So stripe 1 is parallel to stripe 2. And I know that stripe 2 is parallel to stripe 3. Okay. Now by the transitive property of parallel lines, that means that stripe 1 has to be parallel to stripe 3. Okay. Well, then I can say, well, stripe 3 has to be parallel to 4. So therefore, stripe 1 has to be parallel to stripe 4. so on and so forth till I get to stripe 1 is parallel to stripe 13. Just keep going down the lines. All right, last example, and then we will be done with 3-3. So it says in the diagram below, P is parallel to Q. So I'm going to go ahead and make the markings. And then Q is parallel to R, which means P is parallel to R. So find the measure of angle 8. Well, guys, if all these lines are parallel, if this is 115, this has to be 115 because they are parallel, or they are corresponding angles. And if this is 115, this is its corresponding angle, so these are the same. Well, now this and 8 are a linear pair, which means they're supplementary. So I can say 115 plus angle 8 is 180 minus 115 angle 8 equals 65 degrees. And guys, just showing my work here, that's an explain your reasoning.